Okay, so when we're doing linear programming, we are trying to maximize a benefit function subject to specific um, delineated constraints. So um, there are choice variables, variables that we have the freedom to select, and then you want to pick the best combination of those choice variables to meet the maximum to get the maximum objective, satisfying all the constraints in the problem. So a good example of a linear programming question or class of questions are transportation problems. So let's suppose that I have goods and they're stored or produced, excuse me, in New York City, Atlanta, and San Diego. And I have warehouses in Topeka, Madison, and El Paso, and Anchorage. All right. So naturally, the production capacity at each of these plants has a limit. So we can think of each of these plants as supplying some amount of goods. So I'm going to write supply here, but we're just thinking in general about problems. So let's say that the New York production facility can produce 10 units, Atlanta can produce 15, and San Diego can produce 8. And then we also are interested in the demand of these distribution facilities. So as customers make orders, then it's going to put in requests from these distribution centers. And so based on the expected demand, we can forecast what the demand would be from the warehouses. And we'll predict that those are 9, 7, 7, and 3. And so we've got now demands from these and supplies from these. These are all constraints. So the goal of a transportation problem like this is to get all the goods from these locations, from the sources, the production facilities, to the destinations with the smallest distance possible, minimizing transportation costs. And so to do that, we need to know the distance between New York and Topeka. And so I'm just going to make some estimates off the top of my head. I'm guessing this is about 2,500 miles, maybe 2,000 here, 1,500. So be 3,000, 3,000, and 2,000. New York to El Paso. It'll be 2,500. Atlanta to El Paso, 1,500. El Paso to San Diego, 1,000. And then Anchorage, New York will be 8,000, 8,500, and 7,500. Okay. So now we've got distances between the cities. We want to minimize that total distance, meeting all the demand and not exceeding all of the supply. So to do that, we need to construct a benefit function. So the benefit function is going to equal the, well, first of all, we have to decide how many of each of these. So for example, New York to Topeka, let's say we ship 1 unit from New York to Topeka. Well, that's going to cost 2,500 in miles, and we'll just assume costs are equal to mileage. So I need to replicate this chart with my decision, with all the different things I can decide. So New York to Topeka is 1. That would be it. So say we ship 1 there, 2 there, 4 there, 3 there, 5. So Atlanta to Madison is 5. 2, and this is just an initial guess, but the idea is each of these represent how many units I'm shipping from New York to Topeka, and I'm going to multiply the number of units times the cost per unit to get the total cost of the shipment. So New York to Topeka, if I ship 1 unit, I'm going to pay $2,500. If I ship 3 units, I'll pay $6,000. If I ship 3 units from New York to El Paso, I'll pay $7,500, and so on. Right. So I've generated now. These are the total costs. If I ship this amount over here, but now the trick is, I want to minimize the total of these costs. So I'm going to add all these up. That's what we're going to be minimizing. Minimize the total of all of these costs. So to ship all of these goods would consume 80,000 travel miles. Now, this solution may not be feasible. So in particular, it has to ship 9, 7, 7, and 3, and then 10, 15, and 8 are the cap here. So we want to minimize the total miles traveled by changing these cells so that we meet all of these constraints right here, these constraints and these constraints, and that would be it. So this is the setup. We are going to pick 12 numbers, and those 12 numbers will constitute our solution because we have 12 different things we're deciding. How, New York to Topeka, New York to Anchorage, and so on. In a linear programming problem, you can often think of it as inputs and outputs, and the total number of choice variables is often inputs times outputs for certain classes of problems. So that's how, just to set up the given information for something like this in Excel. In just a second, we will solve it using Excel Solver and then do the same process in QM.